So today we're looking at applying trigonometry on page 194. So realistically, when we're talking about applying trigonometry, we mean, can we use it in worded situations? So if I give you a real life situation, can you take a triangle out from it and then find a missing length? The other day we did an example with Nikhil pointing at the top of the building. That is exactly what we're going to be doing today. So there are 4 steps to applying trigonometry. The first one is to draw a diagram, and realistically, you should be drawing a diagram every time you're working with trigonometry if there's not a triangle provided for you. But draw a diagram and then label the key information. So things like maybe this length or this angle, whatever it is, that's the key information you guys need to be including. The second step is to identify and draw the triangle. Pretty straightforward. You guys already know how to do that. Step 3 is what we've been doing over the last couple of lessons, which is solving using trigonometry. And when I mean solving using trigonometry, I mean finding that last variable. That bird is obscenely loud. Finding that last variable, for example, the missing length or the missing angle, whatever it is. And the last step is to just write your answer in words. So for example, 15 meters or it's 16.3 kilometers, whatever it is. That's stuff you guys have done since year 7. So those are the 4 steps. We're just combining what we already know. There's 2 things I want to mention before we continue. Angle of elevation and angle of depression. What does elevation mean? Up, perfect. Elevator. Elevation means to go up. And what does depression mean? Down. Yes, down. Exactly right. It means looking down. So we'll put that into application. But let's say I am at the top of a building and we'll try my best to draw an actual building. That's a building. Oh, God. There we go, that's the building. And I'm at the top of the building and I've got an angle of elevation about 30 degrees. So let's say that's flat. If I'm angle of elevating by 30%, am I going up or down? Up, perfect. So it might look like this, and that angle there would be 30 degrees, and that's an elevation. Yes? For a moment I thought you were going to define what depression was. Now let's talk about depression. So what's the angle of depression? It's looking down, right? So I would look down 30 degrees. That's pretty straightforward. How do you guys feel about that? That okay? Awesome. We're going to jump straight into an exam because this is a really example heavy one. So I'm going to pause the recording, type this question out, and we'll continue. So the angle of elevation, so that means we're looking up or down? Up, thank you very much. We're looking up at the top of a tower. So I'm going to draw a tower, and once again, you guys probably won't be able to draw as well as me because is that a bet? I don't bet. That's bad. There we go. That's a tower. See, perfect rectangle. I've got a tower, and the top of the tower is an angle of elevation. So I'm looking up towards the tower. I'm standing 30 meters away. I'm hearing a lot of chatter that I shouldn't be hearing. Thank you. So I've got this tower. I'm 30 meters away. So that line is 30 meters long. And I'm looking up because it's an angle of elevation, right? So I'm looking up at 28 degrees. So I'm going to be looking up this way. And that angle there is 28 degrees. Does that make sense? Yes. Yeah. I'm looking up 28 degrees. I've got 30 meters there. What I'm going to do now is I'm going to actually take out the triangle. Good. I'm going to use trigonometry. I'm going to draw out this triangle here. That's not the preferred triangle. There we go. First try. So I've got a right angle triangle over here because I'm assuming the tower's straight up, right? This is 30 meters. And this value over here is 28 degrees. Does that make sense? Perfect. What are we looking for in this question? What in the question, what's the second sentence? Perfect. We're looking for the height of the tower. So would that be this line here? Or this line here? The first one, right? So let's just call it H. You can call it X, doesn't matter. I'm just calling it H for height. So now let's go ahead and label our hypotenuse adjacent, blah, blah, blah. Yes? This one? Yeah, that's my hypotenuse. Too easy. What else do I know? Your adjacent 30 is A. Good. 30 is A because it's touching that angle there. Good. The opposite's there. I personally like using different colors just so I know that it's not, the length is not O. It's just H. But that's just up to you. So I've used different colors, and we can see that we've got hypotenuse, adjacent, and opposite. What values do we have?
Use O and A.
You guys are skipping ahead. I'm seeing you guys are very confident with this, but you're right. I have A, and I'm looking for O. So which one of my my functions? So we know that so, ka, and toa. You guys are going to refer back to that. We're going to see, okay, which one has O and A? We know it's this one right there. And so I'm going to write, okay, the tangent of what angle we're looking at?
28 degrees.
Good, 28 degrees. Equals to, what's my O?
30.
Is it?
No, it's H.
H, good. Remember to look back at the triangle.
30.
Divided by 30, perfect. Now, I don't want H over 30 because that's what's giving me, a 30th of H. I want just H. I multiply both sides, right? I multiply both sides by 30. Because that way, I know that these two cancel out. And I get tan of 28 degrees times by 30 equals to H. Are we okay with that? You can absolutely do that on your calculator. So after you do that, you just chuck that in the calculator and your H gets 15.95 meters. So don't forget to write your answer in meters. Any questions? Would you guys like to do one more example, or you reckon you're good to get into the questions?